In this video, we're going to introduce a different form. It's called point slope form. It describes a linear function, and it's just a different way to write it when you're given different information. So the form looks like this guy right here. These are subscripts, so again, think of it as like the slope formula. These little guys right here just means that's one x value on the line and one corresponding y value on the line. It doesn't mean we raise it to the first power. So this is just one of the ordered pairs on our line. This guy's going to stay as y, and this guy's going to stay as x. That way it can represent all of the other infinite amount of points on the line. So example 1, we're going to write this equation using slope-intercept form for this line. So if we're given slope and we're given a point, it would make sense to put this in point-slope form because that's the information that we have. However, the answer wants the final form in slope-intercept, which is y equals mx plus b. So first, we're going to write it using the form that we need. So this is one of the points on my line, and I have my slope. So if I fill this in, I'll have y minus 0 equals my slope times x minus -3. This is called point slope form. The question, though, wanted me to put this in y equals mx plus b. So we do need to simplify this and get y by itself. If you notice here, we're going to have some minus a negative, so that becomes plus a positive. That's going to happen every time. The negatives in this formula change the sign of whatever this number is. So keep that in mind for the next example. Now we're just going to go ahead and distribute. So we get 5 over 2x plus, if we distribute here, this is a 3 over 1, we'll get 15 over 2. And y minus 0 is equal to y. So this is now in y equals mx plus b form. Okay, now we're going to graph from point slope form. So when you notice something is in point slope form, remember this is y minus y sub 1 equals mx minus x sub 1. So because we're writing this in point slope form, those are the two things we can identify when given the formula. M should be whatever's right here in front of the parenthesis. So we have our slope, which we know we count rise over run on a graph. And then our point is kind of the harder one to identify. Remember I said this negative is going to change the sign of whatever x value we plug in. So if it looks like positive 3, it started out as originally a negative 3. If it looks like negative 4, this changed it. It started out as a positive 4. So when you're identifying x and y's from this form, your x and y actually appears to have a different sign as it does in the equation. Again, those minus signs change the sign. So again, we can think of this as our starting point. So we're going to put that on the graph at -3, positive 4. So here x corresponds to -3 and y corresponds to positive 4. So my point goes here. And then I'm going to rise 1 and run 2. So up 1 over 2. I can do that in reverse order as well to come up with another point. And we graph the linear function. Now we're going to write an equation giving 2 points. So again, it says write an equation in slope-intercept form. We do need the slope, no matter which form we put this in. So we are going to find the slope first. Remember, here we have 1 point. Here we have a second point. And the slope formula says the change in y over the change in x, or y2 minus y1 all over x2 minus x1. So we're just going to subtract our y values. So we're going to have 2 minus -4. And then we're going to have 3 minus 1. And if we simplify, we're really going to get 6 over 2, or a slope of 3. Now, again, think about the information that you have. We have a point, and we have the slope. So it would make sense to write our equation in point-slope form. So you just need to pick a point. We need 1 point on the line. We have 2. Pick one. I'm going to pick this one because it's positive. So we're going to have y minus the y value, equals our slope, x minus the x value. Again, I'm just writing it in this form. If you wanted to, you could choose the other point. And if we used that point, we would get y minus the y value equals our slope, x minus the corresponding x value. Both of these are correct, but we're not done yet. The question said to put your final answer in slope-intercept form. And that means we need to get y by itself. So no matter which one we choose, if we simplify it, we should get the same answer. So here, if I distribute, I get 3x minus 3. Here, I'll get y plus 4. And if I get y by itself, I'm going to subtract 4 from both sides. So I'll get y equals 3x minus 7. If we were to do the same thing with this other equation, we'll get the same answer. So if I distribute, I'll get 3x minus 9. And now if I get y by itself, I'll still get y equals 3x minus 7. Either equation is correct. So to recap, we have two forms for linear functions. This guy is really helpful for graphing, but that's kind of really it. This guy is also useful for graphing. This one is actually, I would say, probably more common throughout your math career at Watkins until you get up to calculus. But this one we probably focus on more often, but it's up to you. If you know the slope in a point, point-slope form makes sense. If you know the slope in the y-intercept, then slope-intercept form makes sense. But they are exactly the same.